intensity of severe storms has increased, combined with traditional impermeable surfaces that typically accompany urbanization, this has resulted in overtaxed stormwater management systems. In an urban environment, rainwater flows over impermeable surfaces, such as concrete and asphalt, and into sewer systems. These systems are often combined systems, designed to collect rainwater runoff, domestic sewage, and industrial wastewater in a common pipe, carrying it away for processing. During intense rain events, these systems can become overloaded, causing surface debris, raw waste, and other dangerous pollutants to flow into natural waterways. The University of Loyola campus is located in a low-lying area of Chicago that naturally collects water volumes during heavy rainfall. In 2000, a master plan was created by Smith Group, designed to tackle this water management issue. Instead of a traditional impermeable surface strategy, the university chose to take an environmentally sustainable approach that included using a Unilock permeable paving system. Permeable pavers are designed with special spacer bars that increase the joint size between pavers so that more water can flow through the joints. ASTM number 8 or 9 or equivalent open-graded joint aggregate delivers the first layer of filtration, followed by subsequent layers of stone aggregate of varying sizes and depths. The space between these progressively larger-sized aggregates creates a rainwater detention area directly below the paver surface in the event of rain quantities that are not immediately absorbed into the subsoil. At Loyola University, the system was designed to handle water volumes exceeding 5 times the amount of a 100-year storm event, and to support vehicular loads, including fire trucks. During winter months, the permeable paver system offers an added benefit of reduced snow and ice buildup. When the temperature is -2 degrees Celsius or 28 degrees Fahrenheit or warmer, the first few inches of snowfall melt due to heat, which radiates through the spaces between the pavers. At Unilock, we're passionate about helping landscape architects and designers solve the problem of excess stormwater by creating sustainable paving solutions in a wide variety of styles and finishes that are as beautiful as they are functional.
Some of the benefits of a permeable paving system from a designer standpoint specifically, there's some really great attributes of design. I don't have to be stuck with a monolithic pour or color or monotone. I've got a lot of flexibility in color, shape, sizes, and finishes that I don't necessarily have in other systems. When we are designing permeable projects, we typically turn to Unilock to see what they have available. They have a wide variety of shapes and finishes and color palette that we find is diverse enough to work with on most every project. So this provided us an opportunity to accommodate visual delineation between a bike lane and pedestrian area, as well as providing walkability. So our clients are surprised by the fact that permeable paving actually is not an added cost because of what we're saving in the infrastructure and the pipes. We put that money into the cost of the paving systems, the full section, and it's a net zero cost in terms of going that direction with permeable paving. By reducing the amount of water going into the city system through our projects on campus, we reduce flooding not only at the campus, but in the immediate neighborhood. A known impact that we would have, but not an impact that was known to the community until these projects were implemented.